Hello again everyone, this is the Swift for Arduino blog, and today I'm going to show you a nice little trick that you can do with Swift for Arduino. Right out of the box, this is to use the internal temperature sensor that's built into every Arduino Uno in the Atmega 328P chip. Not a lot of people know this, I guess because it has slightly limited usability for reasons that I'll explain in a little bit. The Arduino Uno actually has a built-in temperature sensor. So if you see the main chip here on the board, you'll be familiar with the analog inputs that we've got here on the right. 6 analog inputs that you've got there. And as well as that, there is a couple extra things in there. There's a band gap reference, which is useful in one of the other blog posts I'll explain for you, measuring by deduction the internal voltage rail. But more relevant to us today, there's actually a temperature sensor that's built into the Arduino Uno, and you can read the values from that. Now, how do we do that in Swift for Arduino? Well, this is really straightforward. So here we can see the sketch, and I've just got usual setting up the serial port, and here's the main loop here. So it's just exactly what you'd expect. You've got a slow read temperature centigrade, that's the call that you're doing. You don't need to pass in these parameters, I'll explain them in a minute. That gives you back the temperature in degrees centigrade, and then we're just printing out the temperature here. It's an integer because it can go negative, so obviously because it can be below 0 temperature, and then we're waiting for a second so that we're doing it repeatedly. And you can see down the bottom here are the temperature values, and right here I've got a laser temperature gun. So you can see that's the temperature is 30 centigrade of my laptop, and we'll just aim the light here on the chip, and you can see that's reading 29 centigrade, which corresponds roughly to, it's reasonably close to the temperature that's being read by the internal temperature sensor. Now, there's a few things that's going on. Obviously, I'm reading the temperature on the outside of the box, on the outside of the package, the integrated circuit, and this temperature is the temperature inside the integrated circuit. So there's a potential for a difference there. But much more importantly, the sensors are not calibrated. So Atmega say to you that basically you need to calibrate it yourself, and the values that you get out can differ widely. I've got 2 Arduino Unos here. There's a couple of test Arduino Unos, and the temperature the readings that you get off them are different by like 20 centigrade, even though the temperature on the outside is reading really much the same if you get it straight out of the box. So in order to make this even vaguely usable, you really have to calibrate it yourself, and that means with something like a temperature gun like this, or with some other kind of device, you need to try and get a range of temperatures and see what values are coming out, basically. So see what values the actual temperatures are and how they correspond on here. And then you can use something like linear regression and try and figure out these values here, which is the offset and TS gain. So if you don't put these in, then it'll use a default, which I just kind of made up internally when I was building this function, which will probably be off, to be honest. It might give you something that's roughly within 10 centigrade of the actual value, but for any serious use you're going to need to calibrate this for it to be useful. That said, that means that this is going to be limited value for some people. And really, you're not going to do better than an external temperature sensor. If you buy an external temperature sensor, you'll get a better value. But if you don't want to do that and you just want to play around with this, then this is a good place to start. So there you go, you can see the call. There's an asynchronous version of that. And yeah, you'll see the details in the blog. Sign up now for our blogs, and keep looking on here, contribute on the Facebook page and Twitter. And above all, go to www.swiftforarduino.com, download Swift for Arduino today, and start programming right now in Swift on the Arduino platform.